You join this with the help of a dotted line. Okay. Now,
This night is cold in the kingdom.
Ritika, what are you playing? I'll remove Ritika. Okay. She'll not get the attendance. Now, so if you see, the chords BC and CD are equal. If you have, if you remember, I had done a theorem in class 9 only, that equal arcs subtend equal angles at the center. If you remember, equal arcs subtend equal angles at the center. That means if I have a circle, I have two arcs, say AB, and I have another arc CD, and say this is my center. Okay, say this O is my center. Then arc AB, this arc AB, if it is equal to this arc CD, then these two angles will also be equal. Okay. Also, in the beginning of this chapter, I told you that if you have two chords, not only two arcs, but you have two chords, say this chord CD and this chord AB. If these two chords are equal in length, okay, then they subtend equal angles at the center. That means these two angles will be equal. If you remember, at the beginning of um, this chapter on circles, I had discussed this theorem. Okay, but even if you don't remember, just refresh your memory that if you have two equal chords, if you have two equal chords here, then they will always subtend an equal angle at the center. Okay, that is what you must remember. Equal arcs or equal chords, whether I say equal chords or whether I say equal arcs, both of them, they will subtend equal angles at the center. So this means that if chord in this our question, if chord BC is equal to chord CD, that means these two angles must be equal. BOC, this angle, and COD, this angle. These two angles must be equal. And how much have we found this entire angle to be? We have found angle BOD to be 150 degree. Okay, in part 1 we have already found BOD. This entire angle we have found this to be 150 as I have written here. So that means what is this angle? This angle will be 150 by 2, which is 75 degree, and this angle will be also be 75 degree. Any questions?
No, sir.
So this will be 75, 75. Okay, both, because both of the angles are equal, and I know the entire angle to be 150. Okay, so that is what BOC is. BOC is this angle, that is BOC is your 75 degree that we have found. Okay, we now proceed to the fourth question. Angle OBD. Which angle is it we are talking about? OBD. Fine. Let me erase all the marks and write what angles we have found already. So this entire angle we have found as 150 degree. This angle we found as 75, and which was equal to this angle 75. So this we know. And the question here is OBD. So we join BD with the help of a dotted line. Okay. So we join BD with the help of a dotted line. Now, OBD will be your this angle, this red angle. So how do you find that this red angle? Can anyone tell me how to find this red angle? Try. It's very simple. There's no, concept of circle involved. Anyone wants to try? Orgodeep,
Sir, yes, sir, say.
tell me how to find that red angle.
Hello. So the angle.
Hmm.
Sir, wait.
Angle OBD.
Sir, what is the answer?
First, tell me how to find. I'll tell you the answer. Orgodeep,
Sir, wait, I'm doing, sir, wait. Sir.
Vivek. Yeah, the answer is 15 degree. Okay.
So then I got the answer.
Yes, and you got it correctly.
Uh, 15. Sir, 50. Wait, just a second, sir. Wait.
Tell me how you are doing. I don't want. I'm not interested in the answer. Tell me fast how you are doing.
Oh, sir, see, these two sides are.
Which two sides? Tell me which two sides. What?
Sir, BC and DC, they are equal to
BC and
DC.
no. We are not. We will not use that fact.
Okay. Then, sir, I don't know any other.
Okay. So if you see this angle, this red angle, we have to find. If you see this, these two are equal. OB is equal to OD because they are the radii, right?
Sure, 75
Radii of
degree,
the circle.
75
That
degree.
means this triangle here, OBD becomes an isosceles triangle. OBD becomes an isosceles triangle.
Yes, sir.
Then if it becomes an isosceles triangle, then opposite to these two equal side must be equal angle. So if I take this angle to be x, this angle will also be x, right or wrong?
Yes, sir.
And this entire angle in this triangle we know to be 150 degree. So therefore x
150. So
plus x
181 is
plus 150 must be equal to 180, right or wrong?
Yes, sir. Like I was
That
doing
means
that, like
solve
this
this,
only, sir, with the lower like that.
x is equal to 15 degree. Okay. So this is how you find. Remember, this technique is very, very frequently used in circles. Very, very frequently used. You cannot miss out on this technique. Radii is equal, forms an isosceles triangle, take the two angles to be equal, and then work it out. This is a very, very usual method. Every year you apply one. Every year a problem is given in which you use this technique. Every year. Radii is equal.
Only a single problem, sir.
It is a part of the problem, not a single problem, not an entire problem based on this, but a part of the problem. You will be using this technique. Every year they give you this. Every year that these two are equal, radii is equal, therefore it forms an isosceles triangle, and therefore these two angles are equal, and therefore you find out the equal angles given that your third angle is given. That is every year it comes as a part of the problem. Okay, so we move on to the next problem here. Now this problem is I might have to draw this because I can't do it on this. It's a very small figure. And to understand cyclic quadrilaterals also, this figure is very important. If you understand this problem, cyclic quadrilaterals, cyclic properties means that you are comfortable with cyclic properties. Okay, so this is what your figure looks like. And it is given to you that these two chords are equal. AB and this point is given as C. Okay, and AB chord is given equal to this BC chord. Okay, and this angle is given to you as 50 degree. You need to calculate, and it is given that this is a semicircle, so AE becomes the diameter. Okay, and you have to find angle CBE. Let's mark in red what we have to find. CBE, this angle. Okay, you have to find first this angle. So if you see the diagram, first of all, can you see cyclic quadrilaterals in the diagram? In fact, I think I have made a mistake here. I don't know how deep this mistake goes, that OECB is a cyclic quadrilateral. OECB is not a cyclic quadrilateral. OECB is not a cyclic quadrilateral because O is the center. O does not lie on the circumference of the circle. So I don't know how I've worked this out, but I will show you the correct method. Follow this method that I'm doing. Okay, so this is 50 degree. You need to calculate the red angle CBE. So first of all, you must observe that there are certain cyclic quadrilaterals in this diagram. You have to identify those cyclic quadrilaterals, and there are more than one cyclic quadrilaterals. Okay, so let's see how we need those cyclic quadrilaterals. Okay, now first of all, we start by saying that this angle is 90 degree. This one, since A is a diameter, therefore angle ABE is equal to 90 degree, because angle in a semicircle is a right angle. Okay, so this angle is 90 degree. Now what else can you see? If you see um, a cyclic quadrilateral here, this is 50 degree. This is the okay. An important observation, first of all, is that okay, this is also joined here, which I forgot to join. This is also joined. Okay, So what you see here is that chord AB is equal to chord CD, right? If chord AB is equal to chord BC, that means they must subtend equal angles on the circumference also. If they subtend, if the two, if I already told you that if two chords are equal, then they must subtend equal angles at the center. And if they subtend equal angles at the center, they must subtend equal angles at the circumference also. Okay, that means these two angles must be equal. This angle must be equal to this angle. So this is 25 degree and this is 25 degree. So let us write this down. Angle AEB is equal to angle BEC is equal to half of angle AEC, equal to half into 50, equal to 25 degree. Reason is equal chords subtend equal angles in the major or minor segment of a circle. Okay, so this is 25, this is 25. Now what can we do with this 25 degree angle? This angle is 50 degree, only this, that is why it is 25 25. Fine. If this angle is 50 degree, you see that this forms a cyclic quadrilateral. This one that I'm marking in red. This is a cyclic quadrilateral, right? With one interior angle as 50 degree. That means what should be this entire angle here? What should be this entire angle here? It should be 180 minus 50, right? We write this ABCE is a cyclic quadrilateral. Therefore, angle AEC plus angle ABC is equal to 180, because sum of opposite angles of a cyclic quadrilateral is 180 degree. So that means angle AEC 50, angle ABC is equal to 180. That means what is this angle that I've marked here? Angle ABC. Angle ABC is 180 minus 50, which is 130 degrees. So what does it mean? This means that this entire angle is 130 degree. And this angle I have already marked as 90. So what must be this red angle of mine? This red angle must be 130 minus 90, right? So our first angle I have found out, CBE, which is 130 minus 90. Therefore, angle CBE is equal to 130 minus 90, which is 40. So I have found out this angle. So I'll just label this angle here so that I may use it later. So this is my 40 degree I found out. And this entire angle I have found out to be 130 degree here. Okay. Now next question, CDE. CDE, which angle is CDE? This one is CDE. Now I need to find out this angle. So how to find out this angle? If you observe again, this is a cyclic quadrilateral that I'm marking in green. This is a cyclic quadrilateral. Okay. You all agree? Cyclic quadrilateral
Yes, sir.
in which you know one interior angle. I just found out 40 degree. So what should be this red angle? 180 minus 40, which is this angle should be 180 minus
180 minus
140.
140.
So therefore, we'll write BCDE is a cyclic quadrilateral. BCDE is a cyclic quadrilateral. Therefore, angle CBE plus our unknown angle. What is the unknown angle? CDE is equal to 180 because sum of opposite angles of a cyclic quadrilateral is 180 degree. So that means CBE is we have found out to be 40 degree. That means angle CDE is 180 minus 40, which is 140 degree. Fine. So second question is done. Third question, angle AOB. Which one is angle AOB? Let me erase this first. We have found out this angle to be 140. Next angle that we need to find out is AOB. This one. How much is angle AOB? That's just a cakewalk. How much is angle AOB? Can anyone tell me what should be AOB? Vivek, can you tell me what should be AOB? Auric,
Yes, sir.
Vivek, tell me what is AOB? This red angle that I have marked, what should be the measure of angle AOB?
So it will be 180 minus 130.
Why
Yes,
180
ma'am.
minus 130? Why?
Sir, 180 minus 140.
Why 180 minus 140? Is it any way related to a cyclic quadrilateral, this angle? See, this angle is at the center, subtended by this arc AB. This arc AB subtend this red angle at the center, this angle. And what is the angle subtended by the same arc on the circumference? This one, 25 degree. So this angle must be just double, 2 into 25, which is 50. Understood?
Yes, sir.
Vivek, you understood?
Yes, sir.
Okay. Angle AOB is twice of angle AEB. Reason is angle subtended by an arc at the center is double the angle subtended by it on the remaining part of the circle. Okay. So this is 2 into 25, 50 degree. Easy one. Fourth one, prove that OB parallel to EC. you need to show that this line OB is parallel to this line EC. So how will you show? Any idea? Or can you give me an idea?
No, sir.
No. Outright no. An upfront no.
Trying wait. Sir, trying wait.
Okay.